In this video, let's take a look at graphing quadratic functions and key features. The graph of a quadratic function is a parabola. There are four important parts of the graph of a parabola. So a parabola is in the shape of a U. So I'm going to draw it right here. That's what a parabola looks like. And it can go up or down until you get later in math when they go left and right. But for now, we're just going to focus on the ones that go up or down. So an axis of symmetry is a line, it's an imaginary line that goes through your parabola and would divide it equally in half. Think of like if you've ever made a paper Valentine and you've had to cut a heart out and you fold the paper in half and you cut half of the heart, but then when you unfold it, the whole heart shows up nice and symmetrical. That's like your axis of symmetry. It's that imaginary line that goes right through the middle, and if you folded it, the two sides would match. So, and it's always written as x equals the x of your vertex, whatever that value is. It goes along with your vertex. So speaking of vertex, in a parabola, we have a point where it goes from either decreasing to increasing, or it's a turning point on the graph. It has lots of names for it. So it's our turning point. It's the middle point. It is also called a maximum or minimum, which we're going to look at in the next box. So the vertex are those points right there in the middle, where it has a lowest point or a highest point, which leads us to the word maximum or a minimum. So a maximum is when you have a vertex that's the very top highest point on your graph. And a minimum is when you have your vertex is the lowest point on the graph. So let's write the highest point is our maximum. So, and that's usually when our vertex, because we're talking about parabolas, but later with other graphs, it can mean other things depending. But for now, it's just where your vertex is the highest point. And the minimum is when the vertex is the lowest point. All right. So a y-intercept is when you have a parabola touch the y-axis, and you'd want to pick out that point. So for example, on this parabola, my y-intercept would just be where it touches the y-axis. So it's where any graph touches the y-axis, or where x equals 0 is another way you could think of it. So where it touches the y-axis, and then it's always where x equals 0. And then the x-intercept is the opposite. So that's where it touches the x-axis. So let's draw a couple of options actually. So I'm going to draw a few more things. Let's see. Let me make that a little better. So for parabolas, we have three different options actually. So I'm going to go ahead and mention that the x-intercepts can be that we have two x-intercepts for a parabola, whether it goes up or down. And you can have one x-intercept sometimes when it just touches once. And then sometimes you can have a parabola with no x-intercepts. So there's three possible options for our parabolas and our x-intercepts. So x-intercepts have lots of things. It's our roots of our function. They're also called the zeros of our function, and they are the solutions. So this one has two. This one just has the one, and then this one has none. And it's where your graph touches the x-axis. And it's also where y equals 0. Okay, so that's it for our parts of our parabola for now. Let's take a look at one good example. So we're going to type in Desmos, our example. So let's see, get it set up. We're going to graph x squared plus 6x plus 8, just to show you an example. So y equals x squared plus 6x plus 8. And we want to know what is the vertex of our parabola. So Desmos is really nice because you can just click right on that point and write it down. So -3, -1 is our vertex. Do you think this point is the maximum point, the highest point on the graph, or the minimum lowest point on the graph? So it is the minimum because it's the lowest point on the graph. There's not a point on our parabola that's any lower than that point. And then it says, what are your x-intercepts? So I'm going to click off the vertex and just on those x-intercepts. So that would be -4, 0, and 2, 0. So -4, 0, and 2, 0. If we were solving this quadratic function, we would just say x equals -4 and 2. But if we want to name the intercepts, we name them as a coordinate since they're a point on the graph. So that's a good thing to make a note of. And then let me click off of those again, and let's find the y-intercept up here a little bit. 0, 8. So let's jot down 0, 8 is our y-intercept. So notice x equals 0 for the y-intercept and y equals 0 for our x-intercepts. And then let's add one little thing that's not here yet. Our axis of symmetry. So the axis of symmetry always goes with the x value of your vertex. So it would be x equals -3. And I'm going to graph it for you as well. So x equals -3, and then I can change that to be a dashed line. And I'm just going to make it orange so it'll stand out nicely. So see how it's the imaginary line where if I fold this green parabola in half, it would line up exactly with the other side. Okay, so that's it for some notes on graphing quadratic functions.